Good morning, everyone, and welcome to the BBSim and Scalability Brigade meeting for May 14th, 2020. We have quite a few items on the agenda for today's meeting, so let's get started. The first item is the migration of the testing pipeline from Bash scripts to the use of robot framework. All the all the jobs have been migrated to the new framework. They are available and running here in Jenkins. As now you see some of them marked in red, not because the test is actually failing, but because we started seeing an issue on the cluster where one of the Kubernetes pod sometimes gets stuck in terminating state, and that that caused the builds to fail. So if we look, for example, at this one, it just ran fine, but the first previous three failed in the cleanup phase when trying to remove all the pods from the cluster. That is something we were seeing also with the older pipeline, and it's harder. It's under investigation, but it's a little hard to debug because it's very inconsistent. It happens maybe once every 5-6 days. But we'll keep looking for it. What I wanted to show you really quickly is how to look at the numbers generated by these new jobs. First of all, we still have the plots that display all the information that we have. In this case, we are only measuring the ONU activation and the port discovery in ONUs. If we go in other job, for example, the one where we check the flows, we'll see that we'll have many more numbers. We'll still have the Volta ONUs and ONU spores that are the time to enable the devices and discover the ports in ONUs. Then we check how long the flows takes to be pushed to the logical device in Volta. How long do they take to be pushed to the OpenOLT device in Volta? How long they take to be pushed in ONUs? I note when you see the numbers being higher than 600 seconds, that actually means that the test timed out. So these last four are the tests that actually succeeded. Another way to see what happened in a particular job is to check, let's take this number 37 as an example. It's to check this file that is collected in the artifacts that is called execution time, that will give you a short summary of what happened during the test and how long each step took. Or you can go and look at the robot framework. This is particularly useful in case of some failures. For each step, as for all the other tests in Volta, you can drill down and see what happens. For example, we were iterating here, waiting on the flows, and we can check that at this point in time, only 181 of the 202 expected were present, and then the next iteration we finally matched them, and the step was marked as successful. Is there any question on these new jobs?
Just a quick question. Like in one of the text document that you had, if you go to one of the previous screen that you had, you're showing one way of looking at. If you look at on top, you had this view. This one, and you have the execution time.
Yeah.
Click on that one. So the time, the duration here, is it like everything start with time 0? Or for example, when you put like, let's say flow validation in Volta, like 157 seconds. Is it from time 0? Like everything is done from time 0? Or is it...
everything is from time 0.
Oh, okay.
So it's the port discovery in ONUS happened 14 seconds after the new activation in Volta.
Okay, thanks.
So that's the same way we were collecting the results before. And we kept it consistent. I think it makes more sense to measure stuff in that way, so the plots actually make sense, because otherwise you'll see the ONU's line being at the top and all the others being in the middle, because the delta between the subsequent step is shorter than the ONU discovery time.
Yeah, makes sense. I just wanted to confirm.
Yeah, that has not changed compared to the previous pipeline. We try to keep everything as consistent as possible. There have been few changes in the way we represent things, because robot output them in a different way, but everything else is still there. All the parameters we had in the previous pipeline are there, with some small difference. Like you don't need to specify anymore the total number of new that is now calculated starting from these numbers. You can specify the workflow, because now when we count the flows, we actually wait to have the exact number of flows for different workflows in a particular status. And you can specify a lot more configuration, whether you want to provision the subscriber in the test or not, whether you care about equal DHCP, HMP, link discovery, or whether you want to profile that build. But we'll get to that a little later. You can now specify very easily how many UNI adapters you want to use for that test, and how many ONOs and atomics replicas, as well as all the custom images you may need, all the custom charts you may need, plus eventually patches in the test repo. Okay, any other question?
Yeah, those look very configurable, which is nice. Can anybody just go and launch a job there, or is it limited?
So Zach can probably answer this question better than I am, better than I can, but I believe you need some kind of permission in Jenkins to do that.
Okay.
Feel free to ask, and I can grant permission if Matteo trusts you.
Okay, thanks.
I guess at the moment it's just given to ONF addresses. That is my understanding.
So I know we gave permission to few people in the brigade that were testing images with particular changes and wanted to verify those changes were not affecting or were improving performances. I think Kent and Meyer can now trigger builds. But if anyone needs to validate images, if it is a one-time thing, feel free to contact me. And I can schedule a few builds with the images you provide, as long as they are available on Docker Hub somewhere. Or if it's something more persistent, we can figure that out.
And if Matteo is not available because he's in a US time frame, feel free to ping me. I have the same capabilities to launch jobs on that system.
Okay,
so,
thanks,
Matteo. Oh, sorry.
Oh, go ahead, Sean.
Oh, I was just going to ask. I missed the first minute or two of the meeting. So what is there a summary of where we stand right now in terms of scalability and being able to support a certain number of ONUs on a given OLT for all the way through to provisioning.
Yeah,
Provisioning.
that's my next topic.
Oh, I'm sorry.
Yeah, I was just showing the
I'm out
new.
of sync.
Hey, Matteo, this is Raj, Sean from Redis. You don't have to go back, but just in 30 seconds or less, when you showed those Jenkins jobs, what does this 1-2-32 mean? I mean, just if you don't mind.
Oh, okay, yeah. The naming scheme is actually, so we have the workflow. If it's different, the default one is AT&T, but I'm going to spell it out in the job names.
Okay.
And then 16232 is the number of OLTs, the number of PON ports, and the number of ONUs.
Oh, okay. 1 OLT, 16 PON ports, and 32 subscribers per PON port, or 32 across the whole OLT?
No, per PON port.
Thank you.
This job for DT is with 512. Then we have these 4 jobs with 200. These 3 jobs for the AT&T workflow with 512. One with 64 and no MIB templates to collect some numbers for comparison with the Golang version of the OpenONU adapter. And then we have 3 jobs with 1024 ONUs. So basically, once this last job here will have a sun and a blue dot, means that we are done with the brigade.
Okay. Thank you, Matteo. Thank you very much. That's all I had.
Oh, Matteo, a quick question from me. Probably I missed, but are these jobs working once an hour, or
they're running once every 4 hours.
4 hours, okay.
And that's because every job takes about 20 minutes, and they all run on the same cluster, so we cannot schedule that many more than that.
Okay. So
then some jobs are a little faster, some jobs are a little slower, depending if they time out or there's a seed.
Makes sense. No need to make it once an hour also.
Yeah, it's also nice to have some free cycles on the pod to run custom jobs in case we need to validate the pipeline or the test or different images.
Yeah, exactly.
One way to give control to developers is to provide keywords on their Git patches, just like we have the hardware test and the functional test. So instead of giving users outside of ONF login credentials, I mean, they could just issue the keywords on their Jenkins, on their Git patches.
That's a good point. That's a very good point. Make a to-do. Okay, I'll take this on and I'll talk with Andy to know what will it take. What will it take to implement this? Okay, so I think if there are no more questions on the pipeline, we can move on to see what the result looks like. But if you have any other question, feel free to ask it. So as we said, we started collecting the result. The pipeline has not changed much, but you probably see a little difference with this picture if you were used at the previous one. That's because we changed some of the numbers that we are collecting the numbers for. The idea is that we're now working on 200, 512, and 1024 ONUs. And each of these numbers have a base job that only checks about activation. It has a job that checks about the flows, and it has a job that checks for the entire build. And for now, we have only one test for a workflow that is not AT&T, but we're planning to add more. And this difference in the jobs will, of course, only apply to when we are checking the flows and when we're checking the subscriber. Because when we just checking for activation, then the workflow is the same for all the devices. So we can see that in the activation job, both for 200 and 512 ONUs, we are in a good situation. The numbers have improved a little bit, around 10 seconds in the Volta discovery, and around 150 seconds in the reporting of the ports to ONOS. So we are in a very good shape with the activation. Unluckily, we still can't activate 124 ONUs, or at least we can't on this cluster. This is something we definitely need to look at. When we start looking at flows, we have one of the jobs that is in particular this job here that succeed but not very reliably. And if we look at the plots, sometimes the flows are not pushed into the physical devices in Volta, and sometimes they are not correctly reported to ONOS, so the test actually times out. Well, when we try to add the subscriber authentication and provisioning to the flows, the job always times out before the flows are reported to ONOS. My suspicion is that the packet ins and packet out that start going through the system conflict with the flows being pushed, creating more traffic. So I think these two jobs are the first one we should focus on, and I know there are already efforts going in that direction. If anyone has different opinion, please let me know. Is there any other question on these numbers?
For the 1024 case, I guess you're using multiple ONU adapters, right?
For the 1020, no, I'm using a single ONU adapter.
Oh, for the 1024 ONUs?
Is a 1020 for a total of 200?
No, I meant the 16 by 32 means.
Oh, okay. The total.
Yeah, the total.
Okay, sorry.
No problem.
Yeah, so the number of ONU replicas, it's a little small, but are written here. So for 500 and 1024, we're running 8 OpenONU adapters and an ONOS cluster of 3 instances.
Okay. Yeah, I didn't see that column. Thank you.
Sure.
Yeah, on line 8 with the 200 ONUs with the authentication and flows going on where it times out on the last column N there. Is there a number of completed flows before it times out that we can see as well?
We can check. So the jobs captures some artifacts that are in this logs folder. So for the logs of the container, we should be able to see the flows in ONOS. So they are all there, but they are in pending add status.
All of them?
I haven't checked all of, looks like all of them. I mean, there may be some added in between. I haven't checked all of them. We are also getting a count of the flows that are in added state. So yeah, all of them are in pending add. And we should get the same information from Volta. Oh, no, we're not collecting the flows for Volta, but I can add that. We're just getting the device list in Volta.
So basically, all the ports have been discovered successfully and added to ONOS, right? And then it goes and tries to configure the flows, and then it sends them out, but then for some reason there's no response, or it times out.
Yeah. So if we look at these jobs, so all the flows went down to the adapters fine, but then they were never acknowledged back to us. And so this is something that we may want to discuss, because once the flows are in the device, we don't actually care too much about the status in ONOS. It will be nice to have them in added state, but it's not mandatory for the system to be functional.
Matteo, are you changing the flow pole frequency from ONOS? Its default value is 5 seconds. Are you using it in default or changing it because polling the flows in 5 seconds, you probably get all of them not added to Volta yet. So as I know, ONOS goes to a retry process in this case. So the traffic in the Volta increases. So it may be better to arrange this pole frequency and increase a bit. And what are the timeouts here? I mean, which timeout do you use for these steps?
For the jobs, so the singular step don't have any timeout, but all of them should complete in 10 minutes. That's the timeout we're setting on the job.
10 minutes, okay.
Do you have any specific timeout that you define? For example, the default timeout in a call for it to wait for something to come back from the adapters? Like
no, I'm not changing any of that.
Okay, so that's still like 10 seconds.
Yeah.
It's because I'm looking at this, right? Like it looks like the flows make its way all the way to the adapters, except it's reporting as pending add, means kind of means that there's a timeout.
Yeah. We can also try to increase the timeout. So do you guys have in mind some difference frequency and timeout that we can check, or we just increase it, let's say, to 15 seconds and 30 seconds?
Increase the ONOS timeout to 30 seconds or 1 minute. So you will see them added after 1 minute, probably, if you set it to 1 minute.
Yeah, but in that way it won't keep.
Yeah.
Okay. Yeah, I'll schedule a few runs with these. Values.
But so I'm in doubt that the increasing the honest timeout will change the result we are observing, because that timeout is only a periodic poll to Volta. And what that does is that if it finds them in pending add after 5 seconds, give it is 5 seconds, it will retry after 5 seconds.
Yes.
So I don't expect that if we see them in pending add at the end of the test, we will see them in a added state after 30 seconds. Meaning that if they are added, either we check for 6 times in 30 seconds, if it is 5 seconds, the timeout, or we check once after 30 seconds. But if at the 30-second mark they are added, they would be added, and they will show as added state.
The difference, Andrea, is that if you keep polling from Volta, that will generate traffic through the stack. So it may potentially slow down Volta. I understand it shouldn't be that much of a difference because we're just doing a read operation, but it's worth a try.
Okay, yeah, then that makes sense. But if that is the case, then we should really understand why it is. But okay, yeah, it's worth a try, and I agree with that. Thanks.
Okay, these are good points. I'll schedule some runs today or tomorrow with these different settings, and I'll show the result on a mailing list. Now we'll quickly move on the next point, that is the profiling pipeline. So we can see it together with all the other pipelines. Again, it failed because of the stack pod overnight. But if we look at build that succeed, meaning that we expect this pipeline to time out because profiling things make them slower. But if we look in the logs folder, we'll see that it collects a bunch of images. Now, it is also collecting, or should be collecting, some pprof files that you can just download and open with your Go tool pprof CLI tools, or it generates images for the same moment in time. Now, how can we read this information? If we look at this pipeline in the execution time, we can see, for example, we are investigating why the flows are consuming that much in Volta. We see that the pores were discovered after 130 seconds, and the profiler is taking one snapshot every 10 seconds. So we can just download all the profiles, all the images for that particular container in that build, and we go looking at number 13 and 14 that are the ones we captured why the flow processing was going on. The profiler generates this kind of images. It describes when it was captured and what was sampled and that kind of stuff, and create a maps of all the methods that were used in that time frame, and then the size of the box represent how much time was spent during that operation. Now, it doesn't necessarily mean that a single call to this operation took all that time, but it may also mean that this operation is called many times during the system. So looking at the big blocks, this picture will tell us which part of the system are doing the heavy lifting at any point in time. And if we look at the various images, we can see that it changed changed quite a bit during different moments in the system. Is there any question on this profiling, or something else you would like to collect and see from this pipeline?
And does it show at the point of timeout of the whole system? Is there a snapshot for that one? Is that the last one?
Well, these are some images I downloaded a little while ago, but if we go and check in here, there should be, I will say, yeah, that the last one. I need to check this because we actually have only 20 while I was expecting 60. So I'll go back and check into this, but this one should be the last one at the end of the system.
Yeah, chances are that you won't find one that will pinpoint you to the problem per se. It will just overall show like how the system was performing at what are the routines that's taking the most time. And then once you go and fix that, and when you run again, then maybe you'll see something else, and then you have to fix that. And then it's an iterative approach. At one point of time, then most of them will be fixed, and then suddenly you will get to what the problem is actually.
Yeah, I agree. It's not a magic wand, but it will tell at a certain point in time where the system is spending the most time. So it at least point you in the direction. Okay, so this job is fairly new, so you may see some small issues, like for example, there should be a timestamp after these numbers. But if you see any issue, please let me know, and we'll proceed to fix this. We're keeping this thing monitored. Okay, moving on with the Jinnah. While looking at the profiling images, I found something we should focus on, and then I found out that we are already focusing on them. And in particular, these two areas are the improvement on flows, group meter, and table updates that Mahir is working on. And then these other Jira Vaults 25 that needs to be worked on once it's on. Mahir, do you want to speak a little bit about this task you're working on?
Okay. So previously we were keeping the flows, groups, and meters in logical device in KV store and in memory. So in order to synchronize the deletion, addition, and modification of flows, we were synchronizing the code on the same logical device. So all of the insertions of the flows were locking on the same lock. So this was causing the insertion process to be slow. So we decided to separate these flows, groups, and the meters from device structure and keep them per their ID in KV store and in memory. So make this flow modifications and additions and deletions parallel. So I uploaded a patch about that. And after a long process, thanks to Ken and Kent, because it was relatively big patch, so we spent some time on it. And as I saw this morning, it's now merged. But the next step is to do the same thing for device structure also. I uploaded the page for this subtasks 1, 2, and 3, and now we should go for fourth one and make the same change for device also. So the next step is to go for that in the next week probably. By the way, if anybody else can take the task and have time to do it in this week, it's welcome.
Just to confirm, are you talking about this number 4?
Yeah.
Oh, okay, that's it.
So by today, this first three subtasks are resolved. I'll change their status, but the fourth one I probably will deal with it next week.
Okay.
So if anybody have time to do it this week, as I said, it's welcome. More than welcome.
That's okay. That's okay if you do it next week, Mahir, because you can follow the same pattern that you did in the logical agent, so it would make more sense, I think, if you're okay with it.
No problem. As I said, I probably cannot take the task this week, so it may be late a bit. If it's not a problem, I can take it next week. Okay.
Okay, but so these first 3 on the logical device were merged today. Did I understand? Okay.
Yeah.
Cool. So I'll keep that pipeline monitored, and we should see some differences.
Sure.
Okay. Thanks, Mahir. So the second thing we saw from the profiling was that one of the most used method in the system as now is this proto.clone, and there is this Jinnah to remove it. I don't know if you want to quickly say something about it, Ken.
No, it's just the proto clone is quite an expensive operation, and there's multiple places where we add a little bit too much safety around those structures, so it's many of those clones can be removed. So it's just the work that's left to do that, and mostly in the logical device and in the actual device agent itself.
Okay, thanks.
Yeah, and I tried some local testing with them removed, and there is a performance gain. It's not massive. It all depends in the use case scenario, but in general, there is a performance gain there.
Okay, and then the last thing I've seen and I have on the agenda is this patch from Serkant that is implementing the first necessary steps to deploy multiple Volta stack onto the same Kubernetes cluster. This is basically letting us configure the core topic so that we can have multiple cores and multiple set of adapters running on the same cluster. So the patch looks good to me. As I left the comment, we need to bump the version also in the volta/chat.yaml file. But apart of that, I think we're good to merge. But I encourage other people to review it. And then there was one last thing that I wanted to talk about, that is what is the general sense of the next big feature that we should tackle in regard of performances, and how can we get more people involved in helping with the actual development?
I think that the next thing is, I think you did quite well there, Matteo, to have all those profile data available. I think the next step is really for us to look at those profile data and figure out areas where we can improve. And then after that, then we can figure out if there is further improvement required and what it will take.
Yeah, that's pretty much what I was imagining going forward. So keep the profiler monitored and see where we can when we get people where we can get the most gain in performance. Okay, this is all I had for today's call. Is there anything else we need to discuss?
Yes, Matteo. Is there a way to also profile the HCD performance, or for example, when you run HCD on different platforms, probably we will see different performance results because of the performance of the hard disks. So it may be good to log also the HCD performance in somewhere. So what in my tests is that HCD always logs something that the read operation takes too much time.
Okay, is there any particular metric you'll want to have from etcd, or is like number of keys, size, number of read and write operations?
I don't have any specific things in my mind, but something about the disk performance might be useful. But can we take such results from the Kubernetes or directly from the HCD using Prometheus or something? I don't know.
Yeah, so I remember, yeah, so etcd, if I remember correctly, directly expose things to Prometheus natively. So you just need to configure Prometheus to read from it. It shouldn't be too hard, and once we have that, we can get some kind of information. We'll need to get to see what kind of matrix does etcd expose, but from what I remember, it tells us the DB size, how many requests per second. It seems it gives us also the memory and some other interesting information. So yeah, we have this Jinnah open to start getting information from etcd, and of course the most information we can get, the better it is. And same as for etcd, we have a similar story to get metrics from Kafka.
Okay, that's good. We already have a Jinnah for that.
Yeah, we don't have any plan for now to try to run them outside of the cluster, but that's something potentially interesting. I'm not entirely sure if the extra network latency will balance the saved CPU resources or not.
Yeah, probably.
Yeah, mostly because the cluster where we're running the scale test, it's a very powerful cluster. So I don't think we're getting to the limit of the hardware that we need to move things out, because we are running everything on a 3 physical server. Each one of them has 40 CPUs at 2.5 gigahertz and 128 gigabytes of RAM. So should definitely
And
be enough.
are those have the SSD disks or HDD?
I think they are. I think they are the traditional hard disk, but I can check. I have to go in the lab today anyway, so I'll double check what their disks are. But I don't think by default we are running etcd in a persisted state, so I'm not sure their disk will actually make that much of a difference. But I'll check anyway.
Persistent state, right?
Sorry, can I miss what you said?
Like you say, etcd is not running in persistent state, but we want to have a volume to it, right? We want to save those data, correct?
Yeah, or at least I don't believe by default we run it in persistent state, and I haven't put any configuration in that.
Oh, okay.
Let's see, this is that cluster. And yeah, there is an etcd data that is mounted in that pod. So I'll have to check exactly what is happening. I thought we were not mounting anything.
Definitely having the data of etcd is very useful, because some of the changes that we're doing may have impact also on etcd. For example, like with my here chain, there's a little bit more data being written to etcd. So it's we need to know if there's any impact on etcd on those or not.
Okay,
so that's very useful.
Yeah, that's definitely something that we want to add to the pipeline.
Okay, thank you, Matteo.
Okay, is there anything else we need to discuss? Okay, I'll take that as a no. So thank you everyone for joining. I'll upload the recording on YouTube as soon as it's available, and talk to everyone either on Slack or next week.
Thanks, Matthew.
Goodbye.
Bye.
Bye-bye.
Thanks, Matteo. Bye-bye.
Bye, thanks.